Hi there, this is Ray Marquiss, Senior Application Engineer with Valin Corporation, and this video is going to show how to use IAI's Servo Press in the speed control holding load mode. We'll have some videos and pictures of the software to show as examples.
I want to talk about the different servo press motion modes. There's a table right out of the manual that I'm showing here, and you can see there are 9 modes. There are 4 speed control and 5 force control. And then inside each speed control, there's position, stop, distance stop, load stop, and incremental stop. It's important to look at this part first because when we go back to the software and we look at these modes, they have a slightly different name. Speed control, keeping position, keeping distance, keeping load, holding incremental load. So basically when you see keeping or holding in the software, that means stopping at, just like it shows in the manual here. The other thing I want to point out is that in the speed control, there's this position stop, distance stop, load stop, and incremental stop. And there are those same 4 modes in the force control. We'll forget about mode number 9 for now, but I'm probably only going to do the videos for the first 4 modes in speed control because the only difference is that in speed control, the speed is held consistent while it finds its position, or it finds its distance in this case, or it finds the load, or it finds the incremental load. In force control, the speed is not held consistent, so it will slow down or speed up based on the resistance of the load that you're pushing against, but it'll still stop at the position. So if I do a speed control position stop or a force control position stop, both of those modes are going to have the actuator move to the target position before it stops. So these modes are kind of duplicated. This mode can be used when we want to make sure we get a certain force that we set in the press motion profile. So in this case, 50 newtons, but maybe the part doesn't get placed accurately or consistently. So if we move in on this part, we're going to touch the part and then put 50 newtons of force. If we work with this one, even though it's a little lower, we're going to travel a little farther before we start pressing, but we're still going to end with 50 newtons of force. These arrows are here to point out the range over which the actuator is going to look for that 50 newtons of force. The top arrow is at around 48 millimeters. That's defined by the approach motion. That's where we move fast, and then we start looking for the part after this arrow or below this arrow. The work search motion defines a limiting position of around 58 millimeters. So if we didn't find a part by the time we hit 58 millimeters, we'd fault out. But then the press program part of the program shows 80 millimeters as the limiting position. So basically, as long as there's a part there, we're going to start looking for it after 48 millimeters, and then we're going to fault out if we don't find it and get our terminating load value by the time we pass that 80 millimeters. Here we are back at the Intelligent Actuator RoboCylinder software, and I've already opened up my program where I've created the speed control holding load, or remember stopping at load value program. It's program number 25, and I've set my terminating load for this work search part to 5 Newton meters, so it's going to gently move or slowly move until it gently touches the part when we see 5 Newton meters of force feedback. Then we're going to go at a different speed. It's going to change from the search speed, which is 10 millimeters, to press motion speed of 5 millimeters. And it's going to go until we see 50 newtons of force. If we don't see 50 newtons of force before we get to 80 millimeters, then we'll get an error. So let's run this and see how it looks in this press program operation monitor tool. I've selected program 25. We'll be able to watch the values in this axis status box down here, and then we'll watch a video. So it's probing, now it's pressing, and it got up to that 50 newtons of force at about 66 millimeters. Now it's going to finish pressing and come back up. And here's a video showing the same thing.
You're going to see the actuator come down and press, and it's going to compress that spring until it reaches about 65 millimeters. That target distance is just a matter of how much force feedback it's looking for before it stops.
Next, we're going to look at what would happen if we increase that terminating load. So we'll just change that and say we need to go to 60 Newton meters of force instead. So it doesn't matter where we start pressing, but once we start pressing, we're going to press until we see 60 Newton meters of load, or we pass this 80 millimeter position without seeing 60 Newton meters, then we're going to have an error. So I'll save that. And we'll run it again, and remember we're looking for 60 newtons of load, so we'll probably see the location change a little bit. It's approaching, pressing. So we went to about 69. If I remember right, it was 66 before and then 69. So now we're moving back up, but we didn't get to that press force that we were looking for. And here's a video of that.
In the previous press video, we saw it stop at about 65 millimeters during the press phase, but this time it's going to go almost to 70, right about 69 millimeters. Once again, just stopping at that force that we set. That's it for this video. Thanks for watching. If you need assistance, you can contact us using the information above. If you call our office, you can ask for automation application engineering support, and either I or one of my colleagues will be able to help you out. Thanks a lot, and be sure to check out the other videos that cover the intelligent actuator robo cylinder servo press. Thanks.